Review of trigonometric identities. We need to recall the fundamental identities. This part everyone should know. So we have sine squared theta plus cos squared theta is equal to 1. Tangent theta is sine over cos. Cotangent theta is cos over sine. Secant theta is 1 over cos. Cosecant theta is 1 over sine, and also cotangent is 1 over tangent. We also have that tangent squared theta plus 1 is equal to secant square. Cotangent square plus 1 is equal to cosecant. Those are the fundamental identities. We also should know the basic double angle identities. Basic double angle, so that means sine 2 theta is equal to 2 sine theta cos theta, and also cos 2 theta is equal to cos square theta minus sine square theta. And we should be able to use this one when you substitute one of them. So we know from the one identity we can solve it for cos. I bring this over. I would have 1 minus sine square and substitute here. I would have that cos square theta is equal to 1 minus sine square theta. And then I can collect this. I would have that. So another one is that cos 2 theta is equal to 1 minus 2 sine square theta. And the same way I can substitute for this one that sine theta, sine square theta, when I solve it from this part, I will have 1 minus cos square theta. So when I substitute to this to the original for sine square, I will have that cos 2 theta is equal to 2 cos square theta minus 1. And then the basic facts about the functions we also should know. So that would be that sine minus theta is minus sine theta. And then this is minus. Then we have cos minus theta is plus cos theta. Tangent minus theta is minus tangent theta. And we have, because this only, if the cosine is even function, goes on the others, it's reflected by the y-axis. So only cos is plus, or the rest is minus. And of course the inverses. Those identities are the basic identities. We also have formulae, and that's also called identities. We also have formulae for the sum cos alpha plus beta, but this will be provided on the formula sheet. And we also have identities for half angle. Half angle formulas, sine half of the angle, and this also will be provided on the formula sheet. So the question that involve identities is establish, example 1, establish each identity. Establish each identity, and we have A sine theta plus cos theta over cos theta is minus sine theta minus cos theta over sine theta is equal to secant theta cosecant theta. We would like to prove this identity. establish means prove it. You cannot multiply both sides because you need to prove that this equation is true. So what do? We start with the left side. This is left side, and we keep arranging until we end up with the right side. So left side, L stands for the left side. Left side of my equation is sine theta plus cos theta over cos theta minus sine theta minus cos theta over sine theta. So first step, what we can do, we can find common denominator of those two. We can find common denominator of those two. So what would be the common denominator? It would be cos times sine, of course. So the first fraction needs to be multiplied times sine theta, and everything will be multiplied times sine theta. And the second fraction needs to be multiplied times cos theta. And we put in the bracket, we need to multiply times cos theta. So now we can distribute the sign. Now we can distribute the sign. So we have sine times sine is sine square theta. Cos times sine is just cos sine. Then we have this minus, and we're gonna put in the bracket because we need to distribute the cos and that minus. Make sure you distribute the cos and the minus. If you are not distributing the cos and the minus, that means you put the bracket. So now we have sine times cos is just sine cos. And then we have minus cos times cos is cos square theta. And everything over common denominator, which is sine times cos theta. Sine times cos sine or sine cos is of course exactly the same, because multiplication you can change the order. Okay, so now we need to distribute the minus. So we have sine square theta plus cos theta sine theta minus this. I'm gonna switch the order to have exactly the same term. So I'm changing the order. It's gonna be not sine times cos, it's gonna be cos times sine. Cos theta times sine theta. And then minus, and minus gives me plus cos square theta all over. And I'm gonna switch this order, so I have cos theta sine theta. Not needed, but I would like to. Of course, never ever cancel this out, because we have addition and subtraction on the way. But what we can do, we can cancel those two out. Cos and sine minus cos sine reduces to 0. So what we have sine square plus cos square. But sine square plus cos square, using the fundamental identities, sine square plus cos square is equal to 1. So what we get, so we are getting that we have 1, sine plus cos is 1, cos theta sine theta. And please check what we need to get. We need to get to secant times cosecant. So this is multiplication. I can separate them. 1 over cos theta times 1 over sine theta. Because when I multiply, I'll multiply top, I multiply the bottom. So I will get the same, it's equivalent. And then 1 over cos is secant. Using the trigonometric identities again. Secant is 1 over cos, and cosecant is 1 over sine. So times cosecant theta, and this is my right side, I put right. So we establish the identity, we prove it, that left side is equal to the right side, and that's it. Example B. Example B. We have tangent theta, cotangent theta minus cos square theta is equal to sine theta. Cos square theta minus cos square theta is equal to. Okay, so we need to change is equal to sine square theta, is equal to sine square theta. So we need to use the identities to change tangent and cotangent to sine and cosine. Tangent is sine over cos, cotangent is cos over sine. So tangent is sine over cos. We're starting with the left side to prove that identity, left side. Times cotangent is cos over sine. And then what we have on the left side, we have minus cos square theta. So now multiplication, I can reduce sine and sine, cos and cos. So what I reduce up to 1. So I'm left with 1 minus cos square theta. But now we can use the first trigonometric identity. We can use that sine square plus cos square is 1. So instead of that 1, I will write sine square plus cos square. So this is sine square theta plus cos square theta, and then I have minus cos square theta, and those two reduces to 0. Those two reduces to 0. So I'm left with sine square theta, which is my right side. So the identity is established. See another example. Another example C. We have cosecant theta minus 1 over cosecant theta plus 1 is equal to 1 minus sine theta over 1 plus sine theta. I will start with the left side. I have cosecant theta minus 1 over cosecant theta plus 1. Since on the right side I don't have cosecant, I have only sine, I need to change that cosecant to sine. So I'm looking in my identities. Cosecant is nothing else but 1 over sine. So I will write 1 over sine theta. Then we have minus 1 all over cosecant is 1 over sine theta plus 1. So now to get this, I need to have in the first position, I need to have 1. How do I get 1? If I multiply this by sine. So what we can do a little trick. We can either find common denominator, rearrange, and we will end up with the same. Or I can just multiply times sine. And what I do on the bottom times sine theta. Both sides I will multiply times sine theta, sine theta. And in that case, I can do this because I'm not changing the value. I multiply times 1, so that's the value. So if I want to do this, I need to distribute that sine theta. Okay, so first 1 over sine theta times sine theta is going to be sine theta over sine theta, because this is like over 1. Top times top, bottom times bottom. And then I have minus 1 times sine theta is just sine theta. All over. Now the same is like over 1. Sine theta times 1 over sine is sine theta over sine theta, and then I have plus sine theta. So this reduces, sine and sine reduces, so I have 1 minus sine theta over 1 plus sine theta, which is the right side. So the identity is established. Now we have C, D. With the identities, we should be able to prove problem like this, that I have cos alpha plus beta over cos alpha minus beta is equal to 1 plus tangent alpha tangent beta over 1 plus tangent alpha tangent beta. Never ever think of cancelling cos and cos, because that's one function. It's function f of x. So we don't need to remember this. We are using the identities sine alpha, cos alpha plus beta. We don't need to remember those ones, but we need to be able to use them. So from the formula sheet, I'm getting those two, and I'm gonna substitute cos alpha plus beta is this part. So what I'm getting cos alpha, cos beta, minus, this is my, of course, left side, minus sine alpha, sine beta, all over, with minus, I'm getting cos alpha, cos beta, plus sine alpha, sine beta. Never think of cancelling, because we have addition and subtraction, so we cannot cancel this out. But then we need to look what we need to get. Look what we need to get. I have 1 in the first position. How do I get 1 in the first position? If I divide by cos alpha, cos beta. So what we can do, we can multiply 1 over cos alpha, cos beta, and if I do something on the top, I need to do on the bottom 1 over cos alpha, cos beta. Okay, then in that case, I need to distribute this. I need to distribute the multiplication to each and every term, and the same is gonna be on the bottom. I need to distribute this to each and every term. So what we are getting, this is like over 1, so it's go to the top. We have cos alpha, cos beta, over cos alpha, cos beta, minus, this is like over 1, so it goes top times top, bottom times bottom. So we have sine alpha, sine beta, over cos alpha, cos beta. And then I have everything all over, and the same story here. This is like over 1, so cos times 1 and 1 times cos, cos. So we have cos alpha, cos beta, over cos alpha, cos beta, mine plus, and this is the same like over 1. So on next term I have sine alpha, sine beta, over cos alpha, cos beta. And then cos beta cancel out, cos alpha cancel out, because here is multiplication. The same situation happened on the bottom, so this reduces to 1, basically speaking. And what we can do here, we can group them, and we have one group is sine over cos. And what is sine over cos? Sine over cos is nothing else but tangent. Sine over cos is tangent. But we need to have exactly the same angle. So what are we getting is, from the first one I have 1, then we have minus, this group is tangent alpha, times tangent beta. okay? And then we have all over. On the bottom, this reduces to 1 plus, and the same situation, I can group them together right here. So I have sine tangent alpha times tangent beta. And that's the right side, so we prove it, the identity is established. Also, with identities, we need to be able to use double angle. So we have example E. We would like to show that cotangent of 2 theta is equal to 1/2 cotangent theta minus tangent theta. I will start from the left side. Left side we have cotangent 2 theta. We don't have the formula for cotangent 2 theta, but we know from fundamental identities that cotangent is cos over sine. So I will have cos 2 theta over sine 2 theta, because that's my one, the same angle. So we have cos 2 theta over sine 2 theta. 2 theta over sine 2 theta. Now we need to know the identities for cos 2 theta and sine 2 theta. I only remember those two, and the rest I work it out as I need. The rest I work it out. So cos 2 theta is cos square minus sine square. So this one is cos square theta minus sine square theta. And sine 2 theta is 2 sine theta cos theta. So now we can separate them. We can write 1/2 times the fraction, cos square theta minus sine square theta over sine theta cos theta. Because multiplication, you multiply the top and you multiply the bottom. So that's equivalent. Now I'm going to undo the subtraction. Whenever we have subtraction, like 4/3 minus 2/3, what do? We go 4 minus 2 and thirds, which is basically 2/3, right? So I have one fraction and I would like to undo it. One fraction and undo the subtraction. So this equal to, I have this 1/2. Now I need to keep bracket, and I have cos square theta over the denominator, sine theta cos theta, minus sine square theta over the denominator, which is sine theta cos theta. And then it's one fraction. We can reduce cos square and cos cancel out. Sine square and sine cancel out. Sine, because cos square is cos times cos. So what we have is 1/2. And what's left on the top is cos over sine minus sine over cos. But cos over sine is nothing else but cotangent. So we have 1/2 cotangent theta minus sine over cos is nothing else but tangent. So this is equal to the right side, and the identity is established. One more example using the formulae. Find the exact value. Find the exact value, and we have sine 15. So sine 15 is nothing else but 45 minus 30. So we can write that this is sine 45 minus 30 degree. And then we can use the identities sine alpha, alpha minus beta. My alpha is 45, my beta is 30. So according to this formula we have sine 45 sine alpha, which is 45, cos beta, which is 30, minus cos of the first angle 45, and then we have sine beta is 30. Then we need to use our chart with exact values. Then we need to use the chart with exact values. Chart with exact values. Everyone should be able to make it. Just a reminder that sine theta was everything over 2. On top is 1, 2, 3, which is root of 1 is 1, root of 2, root of 3. And this cosine goes backwards, and tangent is sine over cos, so we can divide that. So now we can sine 45 degree. Sine 45 degree is root 2 over 2 times cos 30. 30 cos degree is root 3 over 2. Then we have minus cos 45 is root 2 over 2. And sine 30 is 1/2. So now we can multiply this out. We can multiply this out. So root 2 times root 3 is nothing else but root 6. 2 times 2 is 4. Root 2 times 1 is root 2 over 4. So we can write in one fraction minus root 2 over 4. You cannot subtract them because you can only multiply roots under the roots. You cannot subtract them.